I'm just gonna show real quickly, and I'm sure there's videos out there, but honestly it's like easier to make one than find one that shows exactly what I want. Show what I do before I do the first power up. So this is a new build with a JB-V2 and a Radix 4-in-1 and a Lumineer something VTX RXSR. And this is kind of just what I do real quick to check all the connections before I power it up so nothing blows. So first I get my meter, my just multimeter, put it on continuity, make it do the beepy thing. So when I touch two things, if they're connected somehow, intentionally or unintentionally, the meter will beep. So I just go and hit the battery rails first. So and this, I mean, there's probably a better way to do it and blah blah blah, but this is just a real quick because I think we would benefit from it. So I'm gonna hit the negative pad on, well, I could just do it here. I'm gonna hit the negative pad on the XT60. I mean, that's convenient. Now, when I hit the back of the connector, which is exposed, I gotta redo that. I get continuity. More importantly though, when I hit the positive side, I get nothing. So that's good. You do not want the negative and the positive touching. So now I'm gonna go through and hit all the things that should be ground, and they should all be continuous. I should not have continuity between ground and, say, the 5-volt rail, or literally anything else. That's ground. That's ground. Even the MMCX connector shielding, it's all ground. Nothing going out to the motors is ground at all. None of those should be grounded. All the ESC motor connections should not be grounded. And I will say that ground wire on my RXSR is right there. None of the other pins should be grounded. That last one. But I'll like hit the shield on the USB connector is part of ground. What I'm really looking for is continuity where it should be and no continuity where it shouldn't be. So I'll make sure and hit everything that should not be grounded. It's probably important that, so the edge of the carbon fiber, you can usually get a connection on the edge there. If something's grounding through your frame, then you might be able to pick it up on the edge of the CF. But nothing else. See, this is all anodized. Anodized covering on aluminum parts. Yeah, I want to hit that base right there, but anodization is not. It's an insulative barrier. But that's all on the negative line. So just for an example, let's see if this CF. Yeah, see, on the edge you can get continuity in the carbon fiber. So I know that the carbon fiber frame is conductive. On the top, it's typically covered with a resin, so you're not going to be able to get anything. That's just the top of the carbon fiber. But if I go on the edge, I can see. So I'm going to test the edge of the carbon fiber frame and ground and the 5-volt rail. Nothing should be continuous with the carbon fiber frame. Yep. So next I'll hit the 5-volt rail and make sure there's no continuity between like the 5-volt line and the 12-volt line. So first of all, I hit the 5-volt rail here, and maybe I'll go to where that pad, I just want to make, sometimes I'll hit this just to make sure that I get a positive test first, and then I'll go to just to make sure my meter hasn't like timed out or something like that. The 5-volt rail on the VTX is isolated, so I don't expect anything there, but I would like to test the 5-volt rail on the FC. There it is. And I think didn't check the camera ground, but I'm going to go to ground and test the camera ground. And the camera 5 volts is actually on the JB V2. That is the only thing that's on the regulated 9-volt output from the flight controller. Nothing else is on that. So I'm confident now that the 9 volts going to the camera is not continuous with the ground, but the ground going to the camera, I don't think that's, yeah, that's not isolated. That's going places. And the video line for the camera is not going to any of the neighboring pads. Okay, so see, I'm testing this camera connector here. So I'm not getting, back at the the flight controller, I'm not getting like a bridge between the pads that are right next to each other on the camera line. So there's no continuity between the 5-volt rail and ground. There's no continuity between the 9-volt rail for the camera and ground. There's no continuity between battery and ground, and there's no continuity between the ground and the chassis and there's the frame, and there's no continuity between anything else that I checked that shouldn't have continuity, and there is continuity between all the ground points that I tested. So you put your smoke stopper on, and then you juice it up and see what happens. This could be horrible. Now I'm going to stop at this point and do a crazy check. Okay, nothing's wrong here. The RXSR is not in anything. So I'm aware right now that I'm going to wrap that somehow, but right now it's not. I'm watching the proximity from there to that post, although it is anodized. So I'm just keeping an eye on things. Okay. Sanity check. That connector is next to that standoff, but I don't think there's any danger there. Like this 30 seconds I take right now has saved me before. Looking good. So that's why, I mean, I mentioned smoke stopper, but all of the precautions that I take and experience that I have has led to me not like smoking anything on a maiden power up in like, I don't know, 4 years. So I still think a smoke stopper will be on a purchase sometime in the near future because it's just a good idea. But that's the kind of continuity check that I do. So right now it's powered up, and I'll use my meter again and go to not the continuity check but the voltage check, and I might check, careful not to have my probes short between pads. I go to ground and maybe check the 5-volt line. 4.86, that's acceptable. Going into the VTX, ooh, that is on the 9-volt rail. The VTX input is on the same voltage regulator as the camera. I forgot how I had hooked that up, because the stack is actually off an old rig. I'll check the battery voltage is 15 volts. Oh, on solder pads, when you're checking connections that have been soldered, sometimes there's flux. If you don't clean your solder connections, which is pretty typical that people don't clean them with IPA after making the solder joint. But if you don't, like I have, and you can just use rubbing alcohol too. So I have some regular, like, over-the-counter alcohol and a brush like this that I've trimmed down to make the bristles shorter and kind of stiffer, and I use that to just go over the whole board and clean all the flux off. The flux has corrosive properties for the PCB, but if you wipe that off, then you can also get a clean connection between your multimeter probes, and that's not why I do it. But if you don't clean your solder connections, then you just have to sort of, if you were going to probe that solder connection, then you might have to just sort of push a little bit harder and maybe work in the probe in order to get past maybe a thin layer of flux that is like encasing the solder ball. Okay, that's all I got.